Welcome back. This is Advanced Geometry with Mrs. RRubright. Today's lesson is 10-2, Find Arc Measures. You should begin by copying the vocabulary on page 649 and the copy for your notebooks on pages 649 and 650. All right, so example 1, finding measures of arcs. Find the measure of each arc of circle P. This right here says circle P. So they just make a circle with a dot in the middle, with the center in the middle, and that's the symbol for circle. That's how you know that it's not an O. Circle P, where segment RT is a diameter. So segment RT is a diameter. They want to know the measure of each arc. Okay. So arc RS. RS is right here. This arc is a minor arc. A minor arc is less than 180 degrees. So it's kind of like an acute angle, right? Like a minor arc. Actually, technically, I scratched that. It's really not an acute angle because 110 is not an acute angle, but it's the smaller of the two. So the major arc is greater than 180 degrees, and a minor arc is less than 180 degrees. Okay, so minor, smaller, major, larger. Minor arcs are named with 2 letters. That's how you know that we're talking about here and not this longer distance. Okay, this is not the distance we're talking about. We're talking about just from here to here. And we know that because we only used 2 letters, not 3. So, RS, 110 degrees is our central angle right here. Therefore, this arc right here is also 110 degrees. Looking at our next one, RTS. So RTS, we go from R to T and then to S. So now this is talking about our major arc, the arc that's greater than 180 degrees. If a whole circle is 360 degrees, what portion is RTS? It's going to be 360 minus what? 360 minus 110, right? It's minusing, you're subtracting this little slice of pizza. 360 minus 110, 250. So this is 250 degrees. And what about RST? Well, where's RST? RST. That is half of a circle. It is a semicircle, right? It's a, right? Hemisphere, semicircle, half a circle. All right, so from RS to T, that's 180 degrees because the diameter splits the circle in half. So we know it's 180 degrees. So we have our semicircle at 180 degrees. We have our major arc at 250 and our minor arc at 110. Not too bad so far. A recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or other person. The results are shown in the circle graph. Find the indicated arc measures. So we're looking for the measure of arc AC. AC. Okay, so how many degrees is the measure of arc AC? 108 plus 29. 137. How about arc ACD? ACD. ACD. Major or minor? Major. 108 plus 83 plus 29 is going to give you 220. Good job. You did that really quick in your head. How about ADC? So going from A to D to C, what did you guys get? Major or minor? Major arc. 83 plus 61 plus 79. No, not 203. You're close, but you had a little bit of a mental math error. It's 223. 223. Good attempt, though. How about the measure of arc EBD? EBD. Major or minor? Major. 108 plus 29 plus 83. Oh, did that say A?
No, it's E.
What does it say? E. Somebody needs to sleep more. E, B, D. There we go. So we could either add 79, 29, 108, and 83, or we can do 360 minus 61, 299. I could do that in my head way faster than I can add the other four numbers. Identify the giving arc as a major arc, a minor arc, or a semicircle, and find the measure of the arc. So how about arc TQ? Arc TQ. Is TQ major, minor, or semicircle? It is minor. What is the degree? 120. How about arc QRT? Discuss it with your table partner and let me know. Major or minor? Major. How many degrees? 240. Because it's 360, the whole thing, minus 120 that's missing. Another thing you could have done is this is a diameter. But they don't say that, and you really shouldn't assume. But being that it is a diameter, and you're not assuming because look, 60 plus 20 is 80, 180, right? 120 plus 60 is 180, which means this has to be 180. That means that this is positively the diameter. So then 180 plus 60. Or 360 minus 120, which was the faster way. Arc TQR. TQR. What is arc TQR? It's 180 and it's a semicircle. How about QS? 160. Good. Because since this is 180 right here, this is 180. So this right here is 160. Good job. You also could have, instead of finding this, if you're looking for these two, you could have done 360 minus those two. TS. 80 degrees minor. How about RST? 180 semicircle. Tell whether the red arcs are congruent. Explain why or why not. Are these two red arcs congruent?
Yes.
Yes, they are. Why? Because they have the same central angles with the same radii, right? They're in the same circle and their arcs are equal. Okay, the measure of their arcs are equal. So if the measure of their arcs are equal, then the lengths of their arcs are equal. All right, so how about here? They're both 90 degrees, but are they the same length? No, because this one has a smaller radius than this one. So these are not going to be equal. They're not congruent. It's freezing up a little bit. Okay. Tell whether the red arcs are congruent. Explain why or why not.
Yes.
Yes, they have why?
Because they share central and something.
The same central angles. The same central angles and the same radii. The lengths of the radius are both equal, so we know that these lengths are going to be congruent. How about here?
Yes.
Yes. Same central angles. They have the same measures, right? They have the same measures, and then they have the same radii. So both their radius are equal. So therefore, these are both the same length because they're the same size circle. They're congruent circles. How about here? No. This one is shorter in length and distance. The portion of its circumference is smaller than this one because this one has a larger radius. Therefore, this is a greater distance here. And that is, well, actually, let me delete that page. That is everything on our lesson on 10.2, finding arc measures. I hope you guys enjoyed today's lessons. Like our video and subscribe for more math lessons just like this one. Have a great day.